Alright, hi everyone. Hi everyone, we're going to start. I know some people are going through the outside still, but we're going to start. So thanks for coming. This is Health Technology Interest Group Elective, and basically what we're going to be doing is we're going to be hosting a lunchtime seminar series. And we're going to be inviting speakers that are clinical innovators in both the public sector and the private sector to come speak with you guys. Today we have a great presentation from Beth and Augustine, who are here today to talk to you about how to start with your ideas in technology innovation, hopefully empower each of you to do the things that you want to do as your careers develop. So without any further ado.
I'm Beth. Thank you. Just to get a quick head count, how many of you are first years? Oh, okay. How many of you are not med students, like from a different school? All right, okay, that's good. How many of you have already developed an app or have done something with technology? All right, okay. So my name is Beth Bryn, and I work for a unit within the School of Medicine Dean's office that really focuses, it's called the Information Services Unit, which that doesn't really mean anything, so we just call ourselves ISU. And we work with faculty, researchers, administrative faculty, all sorts of different kinds of people who want to try to do something interesting with technology within UCSF. And so all of the work that we do, all of the stuff that we do is really about figuring out how to get stuff done within the university. Usually it's for, it's grant funded, or it's grant funded, or it has funding from someplace else. We don't fund anything ourselves. People come to us with ideas that they want to accomplish. And so we do, I'm just going to go briefly over this. I think it's important mainly because we do support. So once an app is rolled out, or once the technology is rolled out, we're also responsible for making sure that it continues to run, which is an important part of thinking about your ideas that very few people actually budget for and do in the long run. We also run the Data Security Compliance Program. So we are sort of the group that gets in trouble if there's a security breach, a technology security breach. And so it's really in our interest to make sure that you're going through a security review process, which if you're going to have any kind of patient data or any kind of student data, actually, you have to go through a security review process. And so we help do that. We also help with understanding sort of what is globally available at UCSF in order to get technology done. We also have what we call a single point of contact, or a SPOC. It used to be called a Geek Squad, and then now we're called a SPOC. I don't really like either of those names, but those are the ones that we're stuck with. But what that means is that if you have an interesting idea, you pick up the phone and you call us and we answer it, and we help you sort of figure out how to get it done. Right now we're working with some folks who want to try to do stuff with NLP. There's not really a center of excellence on campus for NLP, so we're helping to try to stitch together how that might be done, what are the resources that are needed, what it would take to do that. Is everyone familiar with NLP, or what NLP means, natural language processing? We also do some things with emerging data integration between electronic health records, and so we're trying to get data from the EHR, other places, and maybe eventually to get data from other places into the EHR without necessarily having to do everything within the confines at EHR. And then we also build things, and the building things is, we don't build everything. Augustine is from one of our partners. She's going to talk to you a little bit. But we do enough building so we understand what it takes to get something done. So we get our hands dirty. Almost all of our work is on sort of small prototypes, pilots. We don't really do like big enterprise builds or anything like that. That's usually some other technology group on campus, but we do the small stuff that really is a proof point. So that's just a little bit about ISU. I think the thing that I want to, these figures and numbers are a little bit old, but I think they still stand, that doing something cool with technology, innovation, is kind of hard. You know, 75% of all startups fail, almost 42% of all products sort of fail as well. And I think what's most important in this one is really cool, is that there are only 36 products on the app stores that account for 50% of all downloads. So there's a lot of competitors out there when you want to build something, you want to try to do something interesting with technology, and not very many people are successful at it. And so what I'm going to talk to you today is about some of the ways in which you could mitigate that risk, and ways that you can think about designing systems and products. So how many of you guys are familiar with this matrix here, this little sort of overlapping of desirability, viability, and feasibility? Is this old news to you guys? Have you heard this before? Or shall I go through it real quick? No. Okay. All right. That's good. So this is really kind of, in order to do something well, in order to do that innovation kind of thing, you want to make sure that it both sort of has viability, actually, that, you know, the cost, you can balance the books on that, both the cost to do it aren't too expensive, as well as there's real value that you're providing. So that's kind of the viability. And that value could be monetary, or it could also be, you know, you have better health outcomes. The viability really depends on who's paying the bills and what they care about. It also has to have desirability. It also actually has to be both useful and usable. So, you know, the people who are using the technology, or the people who are supporting the technology, or the people who are responsible for incorporating the technology into their workflow need to actually want it or see some value in it. So it has to have like desirability. And then it also has to be like sort of technically feasible. And to be frank, almost everything is technically feasible. It's just really expensive to do, or nobody wants it. So technology usually isn't the problem. Sometimes it's the problem, but usually it isn't the problem. And so this is really this intersection of how to find something that both has a business case behind it, has the usability and usefulness that you need, and is also technically feasible, is sort of where we like to try to design products, design technology products that have a good sense. And so the way that my group does this is through a discovery process, and I'm going to take you through this in more detail. But this is usually an upfront project, which is really about making sure that you've understood the problem at least well enough, and that you've understood the problem on all of these intersecting things, so that you can begin to actually build something, right? And so I'll walk you through sort of this in more detail, but it's really about making sure you spend some time up front understanding what the problem is and understanding what the solutions might look like, and begin exploring those. And then my group follows an agile development process. There are other different kinds of development processes. We just happen to do these in sprints, where you have specific deliverables in 1 to 3 week cycles. Lots of smaller technology groups work in this way, and it's called Agile. And there's like backlog, and and it's really sort of just a vocabulary about sprints, about how to get work done and how to get technology work done, that is really quite popular. I think the thing that is most important about the Agile development process is that if you choose to use this methodology, this means that you are, as a product owner, as someone who has the vision for how this is going to happen, you need to be closely involved with your team as they're going through and showing you deliverables and saying, oh yes, it looks like this, oh no, it doesn't look like this, oh I need to do this. And it's really this sort of development, this being in sync daily or at least weekly in user reviews to understand what it means to build something. And I think sometimes it's so easy to build something and for people to go off and come back, that there's often a disconnect with really sort of meeting a vision for what you want. And so this is a process that we found works really well. Does this make sense? Are you guys, is this appropriate? Is this useful?
What does Agile refer to?
Agile is just the name of the process. So there's also waterfall. It's a different development sort of process. You could also call it Scrum. Scrum is also a different sort of version of this. There's extreme programming. It's all just sort of a process for how you get technology built. Does that make sense? And it's not that important to know, it's just something that's really common, a really common development process right now. So I'm going to talk a little bit about what a design and discovery sprint is. And so you'll remember here that this sprint here is how we like to organize work, and it means that there's a group of, a team sort of focused on doing something at one time, and we refer to them as sprints. But you can call them projects, you can refer to them as tasks, it doesn't matter, we just like to call them sprints because we like to use new words in technology. And so we usually, when we do these discovery projects, they're usually about 40 to 60 hours of work, so about a week or a week and a half worth of work. But they usually go on over 6 to 8 weeks, so 2 to 4 months of, a month to 2 months of focused time really doing all of these tasks. And so really the first thing is really understanding what your idea is and why. And so specifically it is like, what will this change? What's going to look different and why is that important? And so we spend a lot of time really understanding what the idea is, why it's significant, as well as what would look different if this didn't exist in the world. And so this is really about trying to understand. And so let me give you an example from a project that we recently did. We worked with rheumatoid arthritis clinic who was looking at trying to find a way to present some patient data back to the patient so that they could understand how they were doing, what the trajectory of their disease was. But sort of the reason was why. Why would you do this? Why do the patients need to know this? Why? And it really was about facilitating a conversation between the clinician and the patient so that over time they could make these adjustments to their medications, because rheumatoid arthritis is a chronic disease that's going to just go on forever. And so they really wanted to be able to track and understand how things look over time, over a long period of time. And so it was really to have more in-depth conversations and to save time about how you were doing so that they could take these measures. We spent a lot of time asking why, and there's some techniques around this called the 5 whys, which is essentially exactly what it sounds like, why. You can also use a technique that sort of IDEO perfected, which is a how might we statement, like how might we, and you can do whatever with this. These are all different ways of sort of framing the problem. And I think that you guys will get in your electives a little bit more around the design thinking and this sort of research thing. The other thing that's really important is to understand who. So being very specific about who is involved in your technology idea, who is involved, who are the users, who might pay for it, who needs to support it, who is going to be around it when that technology is developed. So again, going back to the rheumatoid arthritis, so although the conversation was really between the clinician and the patient, it turns out, and this is something we only discovered after sort of doing this project, this prototyping and doing the discovery project, that it turns out that the medical assistants, the MAs, are the ones who are going to be most impacted by this technology, because they're the ones who are going to chart what's going on with things, and they're also the ones who the patients are more likely to ask the questions of, is this good, is this bad, rather than bothering their clinician. And so, again, really understanding the who and where that is. And it turns out the MAs were all for a technology solution for this. So again, I think it's really understanding who else. You also want to understand what the competitors look like and what the ecosystem is. And so this is, are the patients already tracking this data through their Fitbit or through their health kit, right? Is this something that already exists? Are we providing a solution that they don't need? So this is a little bit of understanding what other systems, what other technologies exist. And a lot of it is just Googling and looking at the iTunes store or the App Store, just figuring out what exists. Then I think the next thing, once you sort of have gotten to this point, is really starting to sketch out lots of different ideas. And I think this is really about describing all the alternatives. So going back to the rheumatology, right? We could create an app that did this, But you know what, we could also just print out a report, you know, in their after visit summary that they would be able to see this kind of data. Like, what, you know, what's the trade-off for this? Like, how could that exist? And there are existing scores out there. How well do rheumatoid arthritis patients understand those scores that exist? So I think it's a little bit about really looking at alternatives, thinking about how this could work. That sketching really helps, and it doesn't really have to be a super pretty thing. It just really is, oh, could it look like this? Could it look like something else that exists? And it's about, you know, sort of taking a screenshot and maybe illustrating it or starting to literally sketch it, right? Adding in contours and things like that, that you start to bring shape to what an idea should look like. Again, this is also very important. I think you really want to make sure that you understand what value your idea is. Is it going to save time? Is it going to save money? You know, why is this a better option? Are there going to be better health outcomes? And particularly, is that measurable, right? It might be a great idea because people might be really happy with it, but you can't measure that. Well, you can. There are ways to measure happiness, but it's not a really easy thing to measure. You can measure proxies for happiness, right? And then the question also is, who do you need to prove it to? What do you need to prove, and who do you need to prove it to? Is this something that is being funded by an NIH grant and you have to actually, you know, prove it scientifically? Or is it something that is going to be proved on the marketplace? Or is this something that is really just going to save time for existing clinicians, and so all you really need to prove it to is clinical systems, that this is a better way to work? So I think really understanding what the proof point is and what that's going to matter is an important thing. Does this make sense? Do you guys understand what I'm talking about? Yeah? I think the other thing is thinking about risks. So remember I talked about the data security part before? So it was like, is there a risk for sending this data to the cloud? How big is that risk? What is the trade-off there? You can do it using a cloud, sending your data not to like an existing database on campus at UCSF, but sending it to someplace like Amazon is a lot cheaper. It's the way that a lot of modern systems are built, but there's a lot more risk that you're assuming there. And so there's some trade-offs, and you need to make sure that you or your development partners understand what that risk is. Then again, I think it is, once you know that there's risk, prototyping and figuring out what you can do, and this is a little bit why ISU continues to get our hands dirty designing and developing things, is because when you actually build it and make it, you can show it and people can say, no, that's not what I meant. I meant something different, right? Back to that agile, being able to look at this and being able to build something and get people's reaction to it is a huge way to reduce risk when you actually have a network schematic, which is something you need to have to get through a security review. And a network schematic basically says, where are people inputting data, where are you storing it, how are you transmitting it, and who has access to the reports. That's really what a network schematic is. You know, that can help you reduce risk. So prototyping is a great way to really understand what you're doing and where the risk is and what you might be able to learn. And then again, there's no point in learning if you can't actually do something with what you've learned. So being able to take a moment and reflect back and understand, oh, when I built that feature and I had 0 clicks or nobody used that, what does that tell me? Do I need to invest any more money in developing a glossary? So this is something that inevitably everyone's like, oh, we just need a glossary. And I'm like, no one's ever going to read a glossary. I guarantee you on an app, no one reads a glossary, right? But if you don't look at that data, you're never going to know. And you're going to spend lots more time investing in a glossary than no one's going to read. And so being able to sort of test and validate this. And this is all before you've really developed something for real. This is all just sort of the initial part. And so this is, again, sort of this test and validation is part of this discovery process. And hopefully, this is one of many tools. There are tons of tools out there that you can find. I like this one because it's compact and visual. It's on an 8.5 by 11, but this is just a product vision canvas. And really, this is about understanding what the vision of my app is, who do I think is going to use it? What needs am I meeting for them, right? What is the product, basically? What am I building? What are my business goals? Am I saving time? Am I saving money? Who else is out there? What does the competition look like? How am I going to make money? What is it going to cost me? I'm paying Amazon, I'm doing this. And then how are people going to actually get it? And this is another thing that you need to think about is you can have the greatest idea, the greatest app, but if you don't have a way to actually get it into people's hands, whether it is by putting it up on the App Store, whether it is by downloading it yourself onto their individual iPhones, whether it is by providing them with the iPhones themselves, you need to have a channel for distributing it. And this is also something that you need to figure out really early on because it can make big differences in how you actually develop your apps. And so, again, these resources are all in the back of this deck, and I'm going to be providing those to sort of the organizers of this elective, so you'll be able to take a look at them in more detail. And again, sort of once you've gone through this, you should have a much better understanding of sort of where your idea fits. Does that make sense? Do these circles make more sense now about what are the questions that we would ask? Yeah? Cool. So hopefully once you've sort of done that, you can do something which is called a minimal viable product. And this is another one of those sort of terms that we like to use, we invented and we like to use in technology, but it essentially means the smallest thing that you can build that's both going to actually work, be functional, work reliably, be usable, and actually have some sort of appeal, have some sort of secret sauce that will actually draw people in. I think a lot of times we think of the in technology, we think about the minimal viable product as being minimally functional, but you really need to have all of these things in order to have something that you can learn from. Did you have a question?
Oh, no,
Oh, sorry. Does this make sense? Has anyone heard the MVP term before? Yeah? No? It's not something you need to know. It's just something we like to create a lot of buzzwords in technology, and this is one of the ones that we like a lot. So from a product roadmap, you can start breaking these down into individual releases, individual features with particular goals in mind of, oh, I'm going to build a glossary because people told me that they did not understand all the drugs that they might have in the rheumatoid arthritis world. So I'm going to build a glossary. They're not going to build a glossary, but maybe, right? That could be something that they would build a glossary. And I'm going to be able to measure whether that's effective or not by looking at how many people actually click on the glossary when I build it. So it starts to devolve into this very specific thing about the technology. Does this make sense? How we get to it? And so then once you get into a little bit of the roadmap, once you've sort of defined your MVP, you can begin to really go through these cycles of continuous learning where you really actually release it and get more feedback as you go along until you have a product ready to launch. And at that point, what are you going to make sure that you do if you're developing at UCSF and you're going to have PHI? What's the one thing that I just told you at the very beginning that you need to do? Security! Security, yes. So you need to make sure that you go through your security review. Sorry, it's a big issue for us right now, so I want to make sure that everyone understands. So let's try that again. What is the one thing that you need to do before you're ready to launch?
Security.
So I'm going to just go briefly through some of the deliverables, and then I'm going to hand this over to Augustina, who's one of our development partners, and she can talk to you a little bit more about what it means to when you actually get into the build pieces. But I just want to get you familiar with some of the sort of interim deliverables that you have in this discovery process that I talked about. So you might have something called a persona. Has anyone ever heard of persona? Which is really sort of a high level, and it can be very fancy or it can be really quite sketchy, right? And this is really like, who is my user, who is going to distribute my app, who is going to be, who is that MA, that medical assistant that I'm talking about? How do I need to design for them? What are the things that are going to drive them to use this in more detail? You could also have a storyboard. This is for something that didn't exist, but was like a Google Glass for being able to do 3D images using Google Glasses, right? And this was, we created a storyboard just to say this is how it could work. And then we used this to get validation about whether people would actually want this or could use this. They didn't. Right? Like this is a lot easier than building an actual 3D app on Google Glasses, right? So it was much easier to get this feedback. You can also use a scenario to really help people understand what's happening and what the process is, right? And so this is a scenario that we built for, this was for a different kind of venture for somebody who wanted to provide social activities for dementia patients, right? And so this is how it could work. And again, this was a lot easier to engage with the social workers about what this product could do because we like storyboarded it out. We said, at this point, this happens and this happens, then building something and not knowing how it was going to work. You could also create wireframes in much more detail about, okay, the app is going to look like this, it's going to talk about adherence, it's going to have this kind of graph. And a lot of times people start here at the wireframe piece without doing some of the earlier stuff, and so you don't know who you're designing for. You don't know if that 75% feels right to anyone, right? You don't know. And this is just wireframes are a good way to do it, but they're only one deliverable in a much more robust offering that you can do. And then this is something that I would love to see a lot more of, which really talks about, because we very rarely design products that are for a one-off use, right? It's really more about how that is through an entire journey, through multiple touch points. This so happened to be one around a kidney transplant app, and this was, somebody came to me and they had this big binder that they give to kidney transplant patients after they get a new kidney and said, we want to make an iPad version of this. I'm like, okay, not like technically, not difficult at all, but quite frankly, after waiting 5 to 7 years, which is how long it takes them to get their kidneys, they're going to be handed this binder that's now on an iPad. I mean, is that really the time that you want to intervene with education about how to use your new kidney? Turns out there were lots of places we could intervene earlier in the process, and so we encourage people to spend money and time up front helping people go get more living donations. You know, like this is really about reallocating funds to further up front in the process, and not about just the technology bill. And we only got that by understanding the customer's complete journey. This is a blueprint, a more detailed version of that journey that's saying who's doing what at which time. And then this is something that we use user stories when we actually go into development, when we're breaking down features. We sort of go down to more detail about who's doing what at what time and what needs to get built. So I'm going to, here's some more resources for learning more, and I'm going to hand it over to Augustina, and we'll take questions at the end, okay? Or unless anyone has any dying questions, no? Great, that's good. I think you need to also actually, just in case. Maybe go over there.
Yeah, we can. Yeah.
So just a little bit of background on Augustina. So as I mentioned, we do development, but we don't do a lot of, we don't do development in every single kind of technology. And so we started working with Rolex a couple of years ago because she had worked with another researcher that we had helped for over a couple of years. And Rolex was a group that was able to deliver Android and iOS apps for us in a really sort of cost-effective way. And so we started working with them, and now, yeah?
Oh, sorry. Wait, so it's, if you come up with an idea, then you would go to Rolex to help you
Develop it.
You wouldn't develop that on your own as a researcher with the idea.
It's sometimes, right? So sometimes people come and we're like, oh, this is the kind of app that we want to keep in-house and you want to develop for some reason. You still have to find a developer to, a technologist to do that. You still have to store your data someplace. And so sometimes there are apps that we develop that ISU develops here. but we have a large network of partners, of which Wallux is one, who when a researcher comes to us or a PI comes to us and wants a particular mobile application, and we've gone through this other process of saying, oh yeah, no, it really is a mobile app, right, this really is the right thing, then we might partner with Wallux about sending you to them. And we can partner in a couple different ways. We have one a person that we're helping sort of the PI think through her features and get feedback on them in a continual process. And then there's some folks who, because of where they are, because of the app they're developing, don't really need that kind of support and are able to work directly with Wallux. So it's just a different way of when you actually get ready to want to build something for reals.
Yeah, and it's basically a co-creation. It's we partner up and we see where we can help. We know we're the experts on technology. You might be the experts on the niche. So basically we're very flexible to that. We know we have the talent and the capability of bringing ideas into solutions, tech solutions. So we help with that as well, because maybe most of the times people come with a lot of problems and an idea of what they want as a solution, but they don't understand how to bring the technology into that particular solution. So we help them through that process. But basically, I'm going to introduce myself very briefly. I'm Agustina, I'm from Argentina. I moved here last year to expand my company, Wallux. It's one of my companies, the one we partner, and we've been working for a few years together, so we're kind of familiar with how we work together. I attended Singularity University. I'm not sure if you're familiar with it, but it's kind of like an innovation hub in Mountain View in NASA. So I went there. It's a program, 7 months. You get to experience exponential technologies and understand on global issues. And then what you need to do is build a company that can actually impact a lot of people through technology. And there I co-founded Muzi. That is a health tech company. What we're doing is we're providing a solution to early diagnostics for HIV in South Africa. And so I might go into that afterwards, but just wanted to give you a brief understanding of where I come from. And from my experience in Singularity University working with UCSF, I've been seeing a trend that reactive medicine is what we're having today, and we're coming to a point where we're going more into what it is predictive medicine. This means that instead of doing something after we found out about it, we're starting to understand that and how to get to that problem beforehand, and we can solve it before. So that's a trend. So it's going to happen, and you're going to see it happening from year to year, and we're going to start having technologies that can be applied to both types of medicine. But I've been seeing this trend for a long time, working with different types of projects. So at Wallux, we really want to understand how can we help to leverage all this technology and help for this industry to grow to its full potential. And that's why we partner with organizations and UCSF, for example. So this is the typical timeline where we find ourselves involved. So as Beth was saying, you really need to understand the problem before you can get to a solution. So if you come with an idea that is very cool because it involves technology, it's not good enough. You really need to understand the problem that you're going to solve before you can implement a solution. So once you have a really deep understanding of your problem, who's the person you're addressing, who's your target audience, who's going to pay for it, like a lot of different things you need to really have handy before you can actually build a solution. We helped through some parts of this problem, through this process, but we really need to understand the problem and understand where we want to get, because we're not going to build something that doesn't have an objective, you know? So basically this is the roadmap. We go through design thinking, then product building, development, and launch. I'm going to explain each of the stages. So design thinking is more about like diverging, like generating ideas, understanding which might be good ideas, good possible solutions to these problems. So we come and use different methodologies, different processes, different exercises that can lead to a lot of ideas. And that might be very, very wide, and we can have like a very divergent and very diverse audience and people involved in the process. We usually use experts in niche, experts in technology, experts in something that has nothing to do with what we're working on, so we can have a more creative approach to it. And not just like a bias thing that is the typical thing we're doing. We're trying to innovate in the health space. So this is about diverging. And then we try to convert using product thinking. So once we have many ideas, we try to grab one and put it into a product that will actually fit the needs of what we're trying to do. And this is where we get to understand the business model, where we get to understand which type of technology we're going to use. We really focus on the product, and we understand, how to communicate it, how to reach that audience, how to deliver it. So that's the part of product thinking, and we help through this as well. Then we go through product building. Once we have an idea of what the product we want to implement, we do this as product building, which involves UX creation and UI design. And this is basically, I usually compare it to building a house. You first need to draw the plans, and then you need to understand where you're going to put like the bed, where you're going to put which wall you're going to paint green or blue, and then you're going to actually develop the whole thing, like create put the bricks, paint the walls, put the furniture. So basically what we do is first we draw an outline of the wireframes, how we will look, we would like them to look. We will put all the screens, and if you click here where you're gonna go, then you put it into a nice plan, and then you actually develop the design that is gonna be the outcome, where you're gonna get all the designs, but it's not gonna work because you only have the drawings, okay? It's only a nice, very nice picture of what it's gonna look. And then of course, we have to go through development. And development works, as Beth was saying before, in sprints. So basically a sprint is a unit of time. We can call a sprint like a week. We can call it like 2 weeks, 3 weeks. It depends on the size of the project. But basically we break the whole project into small modules. And we say, okay, in these 2 weeks, we're gonna do this, and these features. And after that week, we make a demo, and we explain all the features that have been built and how they work. And then if that doesn't fit the need of what we actually wanted to build in the very first time, we go back and we decide maybe to iterate a little bit, or maybe to do it again because we didn't get to that point. And so it's kind of like a path, but it's also a circular path, because sometimes you can't go to the next level if you haven't solved what you really want to solve in the very first place. And you can start building on top of something that's going to break.
At the end of every sprint,
Yeah.
do you analyze your progress? Do you have support group where people give you feedback on what you're doing?
Sure, we work all the time with feedback. So basically the demos are meant to be for that. So we do not want to build a monster without having any feedback. So we really want to know that after a 2-week sprint, for example, we really have what we want to do. We get feedback, we try it, and if not, that's not going to work, because we're going to start building things on top of something that is already not working. So it makes no sense.
But just to clarify,
Sure.
I don't think that you actually launch it to your end users
Oh,
or
yeah, sure.
your product, the people who are actually going to be using your product in that 2 weeks, unless you've already deployed something and you're just doing small iterations. So like Amazon does, they release, I forget how many times they release new code, but it's some bizarre, a huge amount. They're always getting feedback, but mostly you're not Amazon. So mostly you're doing something and you're releasing it, and then you're looking at statistics for, once you have an actual release, not just every 2 weeks.
Totally. So basically, it's, sorry if I didn't explain it well, but basically it's like you get feedback from people around you. It's not like you're gonna have it tested in the real actual audience. But you, for example, I'll come to Beth and say, hey, what do you think about this? And maybe she wasn't involved in the whole process, but she sees that and she says, oh, this is not working. But yes, what we do to actually get a validation of the hypothesis is we break the whole project. If you're building like a very big project, into what Beth said before, like an MVP, a minimum viable product, which is like the basic stuff we need to get into a product so that we can validate that we're actually building something that makes sense. And in that moment, that might be like a, 3 to 6 months period of development where we're gonna have many sprints to get to that point. And after that MVP is finished, then we go and we actually test it in the real life. And then we can start building the next version. But first we need to validate something that is already working. Because it might happen that after a sprint or two, we get a button to work, but it's not something that's useful already, like the button works and it goes to another screen, but it's not something that you can already go to the market and say, hey, use my app. Okay. And this is basically how our team works. We work with Scrum methodologies, and this is basically the components of the team. So you have developers, people who are computer science experts or software engineers, electronic engineers, and then you have design thinking experts, you have product thinking experts, product building, and then you have a team manager, which is your point of connection. So basically you have, what we do is we partner with people who are most of the times experts in the niche, so they are experts on what they do. So we are the experts in technology, they are the experts in what they're actually building. So we team together, and this is like more the overview of the technical skill, the technical team. And the point of connection is most of the time through the team manager, which is the person that manages and takes care of the product from a technical perspective. But of course, like everyone is interacting all the time. So as Beth was saying before, I'm happy I got this into the presentation. We've identified several things that are very important for the health care sector when we're building digital technologies for it, because we work in very different industries, and we have identified some very critical things that we need to take care of. And for the healthcare sector, we're actually dealing with very sensitive information. We're dealing with information of patients, and we're dealing with information that might be something that people don't want to show and don't want to tell everyone. For example, I'm working on an HIV application, and people don't want to have other people know that their status, you know. So it's like a very difficult topic when you're dealing with technology that we're all like about like showing everything and storing everything in databases around the world, distributed. So you need to take a lot of care of how you're building your platforms. So basically we do very secure platforms, and we take care of where we're storing, that it's actually going to be accessed only by people who are meant to be to have access to that. And we also need to be focusing on the fact that we're dealing with people. And of course we're dealing with technology, and it's something like sometimes it's robots and sometimes it's an app, but we also need to really understand that there's people on the other side. So there's a reason of why like sometimes you need a doctor to be telling news. But sometimes we can actually find a technical solution to that, but we never need to like forget about that fact. And it's something you really need to have in mind. And also, I put geolocation here, but it's mostly that we can really gather a lot of data from the context of where we're actually getting the data. Because, for example, if I input some data here in my cell phone, then I can actually get where I'm standing, at what time it is. So a lot of data that can give me more context and can help me use that information for, I don't know, build some very great epidemiology data or something that is more relevant than just the fact that I'm inputting data. Okay? So this is an overview. I'm not sure if you want me to go through this, but it's like this is some trends that I'm seeing in the healthcare sector. So I just wanted to share with you so that you get inspired. But there's a lot of babies and trackers and different devices on IoT getting to the healthcare sector. So this is, for example, a tracker for the heart rate of the baby when they're sleeping. This is, for example, a very funny application that gets parents to know when they need to change the diapers of the babies. This, okay, so it's very interesting how we are actually getting the greatest talents, the greatest experts to very rural areas, and each time, you've been seeing this for a long time, right? But now it's actually becoming a reality that you can have like the best doctors in every single point of the world, and this is something amazing. Then it's also getting to apply to cars. We're getting tattoos, but we're also getting implants and epidermal electronics. I have some friends that have like some information for their health in the wrist. So like if they have an accident, they can easily have like their blood type and pretty much a lot of information from what they need. Then we have a lot of non-invasive technicals to visualize our bodies, but also to teach. It's very important that kids are starting to go to school and understanding where their organs are just by wearing a t-shirt and having a cool app with augmented reality. Then there's a lot of like things for health and wellness trackers. It's mostly IoT. You can put it in your clothes. You can put it in like Fitbit. We can even have a Muse for meditation, and it tracks how you meditate, and it gives you feedback. Because what happens, like I'm a terrible meditator, but I really need to meditate. So I use this that it measures my brain waves, and it gives me feedback of how I'm performing. So I usually said, okay, I'm gonna meditate, but I'm not sure if I'm meditating okay or not. So this gives you feedback, and it gives you feedback in the form of sound. So when you're actually getting it right, which is, there's no right or wrong way to meditate, but it's something like concentrating or something, or not concentrating on something. So you get feedback. For example, you get like birds singing when you're doing it okay. You get like a very terrible storm when you're not. And then you can track like how you perform and at what time you meditate. Sure.
Oh, no, I'm just saying we have 1 minute left.
Yeah.
We have 1 minute left.
Oh, okay. I'll rush. Okay. I just wanted to say like I wanted to give a very, very quick overview on some things we have been building. So this is Fitbit. It's a smart lighter. We built the application that goes together with the smart lighter, and it's basically a tracking method to actually get people to quit smoking. There's a video, but you can see it afterwards. I might just go back. This Canon Health. It's a platform that actually I just got a call yesterday from the CEO. He was saying like we need to integrate more and more modules. So it's basically like self-management solution, and it's covering all these points for now. But now it's like growing and growing and growing. It's an LA company. It's really, really good. Then it's Prime that we've been working with UCSF. I really wanted to emphasize on this one that you should really, really talk to Danielle. She's great. You should really look into this one. These are some of the screens we've been working. It's basically an app that can help to people with schizophrenia manage their lives in a more proper way and healthy way. And this is mostly the company I founded at Singularity University for early diagnostics in HIV. We're basically solving the problem of accessibility and social stigma as opposed to actually building a new solution for testing. And this is some of the screens. We want to make it both hardware and disease independent, so we can scale it, not only doing HIV, but doing a lot of diseases testing. And that's it. I just wanted to show you Lucy, and thank you.
To present, and thank you everyone for coming today. If you haven't signed in, make sure you sign in the back. And next week's talk will be so we'll go over the course and then how everything relates to each other. We'll have talks about medical devices and critical. This is all going to be covered next week. Thank you for coming today. Remember to sign in. Any questions? We'll pass on there.
Yes, I can pass it.
Okay.